Okay, so let's continue from where we left off. So databases, we now talking about relational databases. Yeah.
John.
If you have a question, raise your hand, please, and mute yourself. Once you join, mute yourself. Unless you have something to say, mute yourself. Yeah. Um. Yeah. Relational databases, they use multiple tables. So here, I think your questions should start coming, so that when you are asked questions, you know exactly. You need to understand why we having different tables, okay, so that we can join them again. We need to know that. Yeah. So multiple tables are used in relational databases. We'll talk more about how to design one. Are you okay? How to design a relational database. And we realize that we need to go through a certain process called normalization. Are you okay? First normal form, second normal forms, and then finally we have different tables which are normalized. Then we can query based on a join. Are you okay? So databases exist naturally as tables, but the tables have a challenge. Like I said, using the Excel as an example, you can see that this is what we call the flat file database. Are you okay? This is really the main thing that people were using. So the sad thing was that you had to just keep on and on replicating it. Anytime you have new data, you have to continue. Are you okay? To the right. And we're going to continue for a long while. Are you okay? And it had its own challenges. One of them was that you had to repeat the data. Are you okay? For the same people as you go, as you update it. So, but later we'll find out. If there's a new person who comes in, then we have what we call the update anomaly, deletion anomaly. These were problems we had with the flat file database. Are you okay? And so that was what led to the breaking down. But the latest database, technology that is being used now is non-relational. It's in fact they call it non-secure. No secure. So the no secure databases, they actually don't require you to structure the data using joins and those things. You break down the table. No, there's no need for that. Are you okay? And so the data is there. It's just technology that has really made this possible. It's possible to quickly search those databases. Are you okay? Because don't forget that the reason for organizing databases is to be able to what? Manage it, assess it, and then to query it. So if I'm able to manage, query, and assess, I don't care how you put it, how the organization was done. Okay? All right. So it's the technology. Are you all right? So we have so many of them that exist already. Okay, we have examples of no secure databases. Try and pull one out for you, but that is really something that is being used a lot. So sometimes when you are querying stuff on Google, they may not be from a relational database as you are being taught in class, as if it's the main thing. Sometimes you don't need to have that. Are you okay? So we need to take note of that. That as what we are being taught may not necessarily be like the ideal thing. It can change based on research. Are you okay? Because relational databases have been there for so many years. Okay, so we have MongoDB, MongoDB, have CouchDB, HD. They have so many of them that are in the system. Are you okay? People are making use of them. All right, so take note of that. It's probably not in the handout, but I think I should stick it in somewhere for you. Okay, and maybe we can all look at it later on. If you are interested in this, you can look at it further. Okay, so secure relational databases, secure, they go together. Secure allows you to query. It's a language that allows you to create a database and all that, to design a database to query. All right. Yep. So let's move on. Let me go according to my PowerPoint now. Okay, great. So there are 5 major components in the database environment. Of course, I think we should all know that. We have the data. I think this sounds like GIS definition, isn't it? It's hardware, software, people, procedures. Okay, I think this one, it doesn't really need talking much about, but the same things that we said about GIS seems to be the same thing that we are saying here. But if you remember, one of the definitions of GIS is that GIS is a database system. So no wonder, no wonder we are seeing the components of a database environment looking like the components of a GIS. Okay. So it's literally the same things you are talking about. And that is why AB and Mohammed, I was saying to you guys that you need to actually appreciate this course so that you can know exactly how to approach your projects. Why? Because it's looking like you need to learn how to move away from the normal databases and then bring in the spatial bits. Are you okay? And once you bring the spatial bits, then it's like as if you are doing GIS. So databases, GIS, they are together as a family. So when you become a good GIS person, you become like a serious IT person. When you become a serious IT person and you start bringing in GIS, you now start loving GIS, and you realize that probably all you needed was your geography and some coordinates, and you'll be fine. So databases work similar to GIS, except that GIS introduce what? A dimension, the spatial dimension. And so data, know what data is, know what hardware is, because in databases, of course, the physical schema means implementation of how data will be stored and things like that. That's physical. That is hardware, almost hardware. It's not hardware per se, but without a hardware, how can you be having memory and storage? Are you with me? All right. So software has got to do with, of course, the programs that are being used. In that case, then we're talking about you knowing your MySQL, your PostgreSQL, your Oracle database, then the MongoDB, all these things, Kubernetes. In fact, there are more. In fact, people have developed a lot of NoSQL, systems that are in the system. It's up to you to go and then read more about it, learn it, fall in love with it. Is that okay? So, as if I'm a prophet, you see, the next topic is the difference between spatial databases and non-spatial databases. You see, that is what I was talking about. I didn't even know this for them, but clearly we need to distinguish between a database that the IT person in your organization is talking about. He probably doesn't know about spatial database, and then your spatial database. What are the differences? The spatial database has the ability to store and access both location, spatial information, and attributes, non-spatial information. Meanwhile, non-spatial database has the ability to store and access only non-spatial attribute information. Okay, so go back to my Excel sheet. This database, which is a flat file database with all its disadvantages, is also non-spatial. This is non-spatial. Are you okay? But then if I want this to become spatial, then the rows should actually store an object. Are you okay? So object ID probably up here. Okay, and now this row probably represents a segment of a road. I don't know if it's making sense, but that is the main difference between. So the spatial entities are being stored in rows or as records. Okay, so when we take one parcel of land, it will be stored as one record. Then we can continue and then add the area of the land, for example. Then we can store ABCD because area is what? A number. Okay, it's a floating number. So now numbers should appear here. If numbers don't appear here, there's a problem. Okay. So this is now a spatial database. And what does it mean? It means I can take this file, I can save it, and then I can pull it into QGIS, ArcGIS, any good software that can consume, are you okay, this as a source, are you okay, of data instead of a shape file. Now every advantage of the non-spatial database system now becomes also the spatial database system also takes all those advantages as well. Which means that if you were to buy a database, you should buy a spatial database so that even if you can't use it for the purposes of GIS and all those things, you can in the future, if you wanted to, then you can go there. All right. So there we go. That's the main thing. Let's continue from the PowerPoint. Okay, so in pictures, locational spatial information is up here by the blue arrow. Okay, then we can have the non-spatial here by the red arrow, shown by the red arrow. Okay, so up there you can see that we have a map. Okay, so the map is an output, okay, from the, okay, it has a link, a direct link with the map on top. The data in table 2 has a link with the map on top. I don't know, I was kind of switching it. But so the tables there in there, table 1, table 2, table 3, all those things, then are like spatial, and then the spatial bit is on top. But the reason we have the spatial bit is because we have what? Coordinates. We have coordinates. Okay, we have longitude, latitude, we have some projected coordinate system, UTM behind it, that is reconciling. So I mean, seriously, it's not a big deal. It's really you having a coordinate system that is, and then interpreting the data according to it. Okay. When you use AutoCAD, in fact, you don't even know which database, which coordinate system you are using. If you plot your coordinates in AutoCAD, you realize that AutoCAD doesn't even know what nonsense is. It's like it knows that you have put some numbers there. You are the one who's supposed to interpret it. You understand what I'm saying? So spatial means location. Location means spatial. Non-spatial means non-spatial. No location attached. Okay. So attributes mean it's like characteristic of a thing. Are you all right? So take note of that. So normally you have what we call the attribute table. The attribute table in GIS means that you have what? A table with all the attributes of a thing. But what thing? A spatial entity, a feature, something on the ground. Are you all right? Okay. So that is that. If you have a question, I think I'll take one question or two, then I'll move on. If you have a question, you can ask it. I'm intentionally giving that space so that nobody will have an excuse to say that I didn't allow you to ask a question. Do you have a question? What's your understanding of what I'm talking about from the beginning up to this point? Databases, basically, I think I'm just talking about databases, what it is. And I'm talking about spatial and then non-spatial databases. Are you okay? So a spatial database will give you a map. A non-spatial database is just a table with numbers, tests, numbers, tests, numbers, tests, a lot of values, but there's no location to it. Are you okay? So that you can't see its location. Are you okay? Okay, since you are quiet on me, I'll move on, which is typical of you. So yes, difference between spatial database and non-spatial database. A spatial database supports special data types for geometric objects. So spatial database supports special data types for geometric objects. What does it mean? Geometric objects talking about, points, lines, and polygons. Okay. A polyline, you can have a line which different types of line strings. Okay. Multi-points. Okay. These are different ways of describing geometries. Okay. So spatial databases can support that. A spatial database provides special functions and indexes for querying and manipulating geospatial data. So there's something we call the geom ID or something like that, like a special unique number that identifies the spatial entity. A spatial database is often used as a storage container for spatial data and non-spatial data. So yes, I think it makes sense to say that. Okay, so we can store not only spatial to spatial data, we can also store non-spatial data. So geospatial, spatial, we're talking about the same thing. Spatial database uses spatial query in geometric functions to answer questions about space. In other words, you can take data which is non-spatial, and then the query you can do is find, let me go back to my Excel so that I look quite practical. Or maybe I should have even opened some SQL. No, but I don't think we really done a lot of SQL. If I want to query this, all I need to do is to select from geom class lecture table. So let's assume that this table is called the name ability table. Okay, so this is SQL and you are querying it for something where area equals, and then I can press enter, and then I can choose this knowing that it's unique. But even if I don't choose something that's unique, it will give me every result that I need. So you can see that I've actually written a query, okay, that will bring me a certain record. And what record is that? So I'm getting every row from this table where the area is 1081. What am I going to get? I'm just going to get this row. So, of course, we will do in a tutorial, and that's why we should be serious with this lecture. Okay? It will be sad if you are in level 400 and you trail a course. It's to be sad. You think people don't like you. So tell your friends and advise them, be serious in life. Tell them that. All right, those who skip the lectures. All right, because I'm not joking. I'm a very practical person. I'm not joking here. All right, so now let's go on. So that query was done, and that's non-spatial. That's all I wanted to say. That query is non-spatial. Now, if you wanted to do something more than that, then you have to do a query. But this query that you're going to do will have to be telling us about a location. So, for example, you can do a query that finds out if one parcel is next to another, that kind of thing, like spatial. A query that finds our distance, for example, are you okay? Or topological functions, things like that. So you can't do topological queries and operations on a non-spatial database. I think that is the point that we are trying to make. So the query I wrote there is purely non-spatial, and anybody who has gone to NIT, learn some database, understands that, but they won't understand something like topological query. You understand that? They'll be totally lost. They'll be asking, what is that? Okay. All right, so yeah, a spatial database uses spatial query in geometric functions to answer questions about space. So like I said, distance, adjacency, okay, queries like that. All right, that can only be done in a spatial database. All right, so that is why if you want to store a document in a non-spatial database and query, you can do it, and then you get a document. AB and Mohammed, I hope you are listening. So you can actually,
yes, sir.
Yes, sir.
You can actually query, for a document by just putting it in the database. If we go back to this, and then we create a new column and say document URL. Okay, then we can now come in here and then point it to where the resource is. So I'll just pick something from my computer. So this is a URL, but it can also represent a resource that is also online. Okay, so I can, it depends on where it is. It's a resource, and that it's just a directory that points there. There can be a file online. I've sent you people documents that were actually sitting somewhere in the US, of course, on the server. So now in a non-spatial query, okay, you can now query this and then get to know that the document exists. But we don't know where that document is. But a spatial database has a special thing with space that it can tell you where that thing is, where that document is. So that if you want to talk about documents in a particular area and associate coordinates with them, all you need to do is to put them into a spatial database by simply adding the URL or the directory path as an attribute. Simple. Now your query then will not only return the document, but it can also tell you where the document is. Okay, a word to the wise. No, this one is not a word to the wise. This one I'm teaching, so I hope you are learning it. Okay, so let's carry on. But you can ask questions as you go. I like questions. Questions help you to understand. That's for you. So questions are good for you. Modify objects. We can change things. Are you okay? In space, we can't do that with non-spatial. Non-spatial means you don't know what SNIT data. SNIT says your SNIT number. They just don't even know where you are. Sad, isn't it? All right. So a lot of companies are migrating their databases and making them spatial. Put that in your mind. So a lot of jobs are there for geospatial people who are doing geospatial. It's coming. Are you okay? All right. I'm talking like a politician. I'm promising you jobs. All right. So now, especially enabled database handle data types such as points, line, string, polygons. Are you okay? All right. Now look at the point. So what it means is that you can just go in there and then decide, okay, I want to deal with polygons, but I put it into the special database. Later we'll find out why. Databases also have an interesting thing of being able to allow multiple users. And then that is where the whole interesting thing begins. So this is just whetting your appetite. All right, so databases which are spatially enabled go beyond your normal table with data in it, period. You can now go ahead and add and get to know the objects which we are talking about. The object doesn't have to be a point, it can be a line. The object doesn't have to be a line, it can be a polygon. So the polygon can be as big as the whole of Accra. And you can say the whole of Accra, I want to associate one thing with it. I want to associate this thing with it. Then whatever it is, you associate with it. Okay, so it depends on how you want it. Now, if you want to break that down, Accra down to districts, then you can be associated with that. So it's your understanding of your geography and how you break it down and the representation of the objects of interest that determines what you have in your database. Okay. All right. So, yeah, example of databases, spatial, like, in fact, there are lots. So when I write things like this, please, it's just to, there are lots. People are doing business. Okay. Now, I've learned one thing about business. Anybody can do business. The market is free market. I heard something like free market. I'm sure that's where they got it from. It's a free market. You come and you see someone is still selling tomatoes. You need to sell tomatoes. They may buy yours. Are you okay? Maybe you are selling better. So all these things you are seeing here, companies coming up with it. Some of them are free. Okay, so what I heard about the free ones is that people just think, hey, we just want to. There's a moral question here that because Microsoft, yeah, ESRI, actually, it's the money they're making. You don't have an idea. So now I think PostGIS, PostgreSQL, they are all there to say if you don't have money, are you okay? So most UN projects want you to use PostGIS, free software to do it, to cut down on costs. Okay, so all these are just examples. Spatial, Hadoop, some interesting names people give to it. When you hear it, you go for it. Are you okay? You will love it. Like I said, there's one they call Kubernetes. I was thinking, is it like coconut or something? Anyway, there's no coconut in there. All right, so MS Access, we've all seen MS Access on our computers since. Are you okay? As Microsoft products. always cracked, isn't it? You know, I mean, seriously, cracking is not a good thing. It's not accepted. Non-spatial database, MS Access is non-spatial database. It has no support for spatial database at the time of writing. Okay, great. Guys, in this lecture, what you want to know, yeah, is what is spatial and what is not. So that when you are asked a question in the exam, you won't be writing the other one. So that when I ask you, okay, you've been given a database that blah, blah, blah. Is this a spatial or not spatial? Then you go and choose the wrong one. So that's the objective. So if you think by now you don't get in the idea of what is spatial and what is not, then you should ask a question, because we will move away from here and talk about something else. Okay, so that's me encouraging you to ask questions. All right. Database administration is very important. You see, administration, management, you know, they kind of go together. Are you okay? All right. At the end of the day, we need to have some kind of, you know, responsibility towards managing a system. And that is also part of administration. Let me put it that way. So think about administration like you are managing something. All right. So at the end of the day, data should be seen to be a resource. That is the whole point in this. So you don't go and install database system on a company's, you know, computers, and then you just leave them like that. Goodbye, I finished installing it, you're out. That means you are just a technical person. You are not a manager. You are just a technical person. So someone who is really in charge of data administration will be interested in the future, how the data will be transformed, how new data will be created and incorporated. Are you okay? Into the system. Are you all right? So database administration, data resource management is an organizational function working in the areas of information systems and computer science. It plans, organizes, describes, and controls data resources. Are you okay? So in other words, you know, there can be a new definition of, for example, we say you own land. This morning it was being said on TV that you don't say you own land, you have an interest in it. So now you have changed the way data is being created, that now we don't even have data on something like ownership. So if you have cadastral records which are showing ownership, then you are now calling it cadastral, you know, your interest, not your ownership. So that job is done by a database administrator via database administration. Okay, via database administration. Data resources are usually stored in databases under a database management system. Okay, or other software such as electronic spreadsheets. And I think it makes sense. I just showed you a spreadsheet. The Excel is a spreadsheet. Okay, so that is the database of a sort. All right. So that is a resource. If you go to a company and the data they have is in Excel, that is like gold to them. That is like, you just don't go, let me just copy it. People go to, I've said this before, they go into companies, someone's office, the director call, oh, come and work on my computer. Next moment, you've copied everything. You have just stolen gold. Okay, data is a resource that has to be managed by a system. The system that consumes it is the database management system, the software. Are you okay? All right. Data administration ideally begins as system conception. Obviously, like I said, the modeling will keep on coming in, that we have to start from conceptual, logical. I think we heard this before, physical. It to be talked about over and over till we are done. Okay, we have 10 minutes. When this 10 minutes is over, please, let's see if you can rejoin. I'll confirm it when this is over, but I think we join for a third time, then we'll end the whole thing. It's all right. I know you are busy. We are all busy. So this online, I think we'll do one more, then we finish. Okay, what time is it? It's 12 o'clock. Okay. So data administration ideally begins at system conception. System conception at the beginning, when you are thinking through it. Are you okay? When you are thinking through it. So now you need to also, you know, do normalization as part of your job, as part of data administration. You are supposed to also normalize your data, make sure that is structured well. First, normal forms. Are you okay? Where data is not, can we talk about it again? It's all right. We talk about what we call normalization as part of these lectures. So data resource management is important. The data administration is all about that. So let's go back. I'll touch on why we're having data resource management. Look at the first bullet, data administration or data resource management. So when you hear of data resource management, don't be scared and don't run away. Okay, embrace it, because they are talking about data administration, which you are familiar with. It's just name, calling it different names. Are you okay? Data resource management, data administration. Okay, so what we're talking about here, the development and execution of architectures, policies, and practices. Okay, so data architecture, how do we collect data? Which data do we need? Let's look at Facebook. Let's look at Twitter and all these people. They have evolved over the years. Why? Because they have people who are actually looking at the management of their data and how it's supposed to be used. And Google even got into trouble that the data that they collected were being used to, give unfair advantage to themselves, so that when you type something and you're searching for this thing, it's there. You put it there, but it's not coming up. Something else is coming up because they have paid and that kind of thing. So we need to understand that there are people who are in charge of the whole architecture and construction of data. Are you okay? All right. And then the policies. So there's policy on data. Are you okay? What data can be stored? There are some projects you can't put the data on Google Drive. Please put all this in your mind and let it have the necessary impact on your life. There are certain points you just don't, you're not supposed to copy the data and use it, to show to any other person, for example. Let's put it that way. Okay. So there are policies. Policies are just, a guiding, principle that helps you, but obviously it means you're supposed to stick with it. Once it's a policy, you stick with it. Policies like police, okay. Practices, things we do, this is how we do it. All right, so development and execution of architectures, policies, practices, and manage the full data lifecycle needs of an enterprise. So the whole idea of data resource management is to manage it, how data is used and reused, okay, and where data ends up, okay. So lifecycle always kind of looks at, how the whole item or resource kind of changes and moves around the organization. So that's when we talk about life cycle, from the beginning where it is created to where it ends up, where it's going, the process, that whole cycle is a life cycle. So data has a life cycle. Are you okay? Now, so data resource management also, so let's look at this one, manage organizations' data needs and information for stakeholders. Okay, so data resource management is also about that. So data is like gold, like I said, it's like diamond, and it needs to be managed. Okay, it needs to be managed. Stakeholders, let me tell you who stakeholders is. Anytime you see the word stakeholders, throw away all your surveying, throw away all your geomatic. Stakeholders may not even know what you're talking about. Stakeholders are people who just are influential and have an interest, okay, in something. They probably are the ones who have made everything possible, and their consents, okay, they have a stake. If are stakeholders, that's what it means. They have a stake in what you are doing. So you need to, as part of due diligence, doing the right thing, make sure that data is well managed. Are you okay? So we are managing the organizational needs, but we are managing it for some people. They are called stakeholders. All right, and they can, of course, they can decide that the whole thing, the whole organization should collapse. I think that's what we should take note of. Or by something, we all know how business works. Sometimes one news of Prince Philip is dead can make a certain company's stocks come down like that. Share values go down just because of one news item. So let's understand that as well. So database management, stakeholders, data resource management. Are you okay? data administration. Let's understand the terminologies. Data resource management is also concerned with both data quality and the compatibility between data models. Are you okay? So data quality and compatibility between data models. Are you okay? So what are we talking about? Data quality has got to do with the kind of data that you are giving me. Can it be used for the intended purpose? I mean, for, it has a whole lot of, errors with it, or it cannot be used for the purpose that I want to use it for. Okay. Compatibility between data models could mean that there's a need for transformation or some kind of, work has to be done on the data. Okay, so data management should look at all that, the quality of data that we are having. Maybe it's not good enough. Are you all right? So my app, I have a new app for, fitness, health and fitness. And you look at the end users, what are they interested in getting? Because it generates data on the person and the kind of exercise that it's taking, So the data you're giving them, maybe it's not good for them. Maybe they want calories and you are giving them their pace, how fast they are running, but you're not telling them maybe they want to know if they've lost weight, something like that. If not giving to them, that's data quality, bounce on that. Are you okay? All right, so yeah, compatibility between models, talk about that. So now with new data, so I said with these data, a new direction, so that we can create new data. Are you okay? And then once you create new data, we can have a new direction for the way the company should go. I think something is missing in here. But here with these data, what I'm talking about is that with the new data that is created, because the whole data resource management should also look at architectures and new things that can be done. Are you okay? And so to create new data. So with new data, we have a new direction for the company that, okay, therefore this company, now we are into this because of the data we are now creating. Okay, that means we should now start going into something else instead of doing what our core business direction is, vision or whatever it is. Okay, the data resource must be managed with the same intensity and formality that other critical resources are managed. So you don't joke with it. I explained to say, someone say, oh, that computer boy sitting in the corner. You don't, if you're a company that values data, you don't refer to people who do IT as some boys. Meanwhile, they are men. Are you okay? You're above 18 years old. They are dealing with one of the most important resource in your company. So data resource must be managed with the same intensity and formality. So you have to have a meeting. You have a meeting. If you have to have some sort of work session where you are discussing, the aspects of the organization that need to be modeled or extended, and the impact on data collection, you need to do it and do it well. Okay. All right, so I was checking if I was recording. Yes, I'm recording. So data resource quality is a measure of how well the organization's data resource supports the current and future business information demand of the organization. How well, are you okay? The organization's data resource supports. So if you have data, does it support, like I was saying, does it support your current and future business information demand? Okay, so it should look, you should now have we need this to survive as a company. We need it, or maybe we need more to survive. So if the quality of data you have is not helping you to